right, let's go, guys. Today I have an amazing guest, a friend of mine, Mrinal, who is a founder of a company called Autonomy. These guys are building amazing agent swarms and technology that actually handles them, and that's what I want to talk about today. But before we dive into the actual technology and use cases and all this interesting stuff, let's do a quick round of intros. So, Mrinal, let's start with you.
Sure. Hey, everyone. Thanks, Jenny, for having me. My name's Mrinal, and let's see, I've been building distributed systems all my life for now 20 to 23 years. And that's kind of been my focus. Basically, systems that involve lots of little components that are distributed around the world, and systems that deal with a lot of data. And I've been thinking about autonomous systems now, I think, for approximately 10 years, especially because of a lot of time I spent deploying distributed fleets of IoT sensors and controllers in many cities around the world. This was this like heavily distributed system. So that made me think a lot about how do you have machines that autonomously operate and collaborate with each other. So that's kind of been a long time coming. And that work led to Occam and now Autonomy. So yeah, that's my background.
Beautiful. So, listen, the reason I'm so excited to talk to you today is because I'm also in the space of autonomous agents. So we're building Ability AI, and we recently launched this platform called Trinity, which is a bit of a different flavor than what you're building. But basically, the objective is also to have an orchestration and infrastructure that is enterprise ready for autonomous agents, intelligence first autonomous agents. But we will talk about Trinity a little more maybe at the end. But so far, I want to learn about autonomy. And what exactly is that you guys are building, and how does it work, and why is it good?
So Autonomy is a platform as a service for deploying autonomous products, for shipping autonomous products, right? So let me sort of break down those words. First, we're building for people who are building products, which is that they have many users. The thing they're building has many users and customers. And now these users might be internal in a company where, we have people using Autonomy to build internal products where their teams have thousands of people internally, or these products might be external facing, like a startup building a product for healthcare or logistics or pharmaceuticals, right? So we're targeting people who are building products, either internal or external. Specifically, we're targeting people who are building autonomous products. And what's an autonomous product? It's a product that
Yeah.
uses one or thousands of agents to achieve some goal that might be complex to do manually on its own, right? So you just give it a goal and it goes and does it.
Mm-hmm.
And the interesting challenge that happens when you're building an autonomous product is you need at least an agent per user of your product. And if you're trying to
Mm-hmm.
do something complex, you might need many agents per user. So very quickly, scale and security and safety become really important challenges, right?
Yeah.
So this is where the platform as a service part comes in. So instead of you having to think about everything that goes into how to scale a set of agents for 1,000 users or 10,000 users or even 1 million users, we've done that thinking and we've packaged it, right? Instead of you having to think about how to do security in this setup, we've done that
Mm-hmm.
thinking and packaged it in an easy way, right? So that's the platform as a service part. So instead of building from scratch and trying to either build the whole infrastructure step by step or cobble together 20 different little services that give you the final product, we just give you a experience that 20 minutes you can launch your first version of your product and then iterate on this live version step by step. So this is all to say we're building a platform as a service for autonomous products.
Beautiful. Look, this is a great pitch. I do have questions though. Can you define what is an agent in this setup? What do you use technologically, and how do you define this one agent? And the reason I'm asking, we will talk about this article you published where you put a swarm of 5,000 plus agents all together. So it's important for us to understand what are the building blocks of that. So tell me a little more.
So in my mind, an agent is a state machine, right? It's a state machine that goes something like this. You give it a set of instructions, it initializes with some context and some initial data, and then you give
Mm-hmm.
it a goal saying, hey, go achieve this goal. To achieve that goal, that state machine goes and calls an LLM and says, hey, here's my goal. How do I get there? The LLM responds and says, you can take these steps. And actually, the LLM usually in this state machine is responding with, take this next step, right? So in an agent, you give the LLM a goal, the LLM says, do this next step. The state machine receives
Interesting.
that instruction. The state machine receives that instruction and it says, okay, the LLM is saying, do this next step. That next step is call a tool, right? Or fetch some data, right? So the way this loop goes is that the state machine gives the LLM a context. The LLM says, do these next steps. The state machine goes and invokes those tools that are the next steps and takes the
Mm-hmm.
results and gives it back to the LLM, and the LLM says,
Mm-hmm.
do these other next steps, right? And this loop continues until the LLM is satisfied as to the goal has been achieved, or you have some exit conditions that say, don't do more than 1,000 steps, right? Or something, right? So that's in my mind a simple agent. In Autonomy,
Mm-hmm.
we modeled that agent as a actor. An actor is this computer science primitive that has been
Mm-hmm.
around since the 60s. It was popularized by programming languages like Erlang or later Elixir and Scala. But in our system, each agent is designed as an actor. And an actor has specific properties, which is that the actor runtime, the autonomy environment that is operating all these
Mm-hmm.
agents, gives the actor the CPU only when the actor has a message for it. So if I have, let's say, 10,000 actors, I can only schedule them onto the CPU if there is a
Mm-hmm.
message for them to handle, right? And I set up a
Mm-hmm.
messaging system between these actors. So that's our basic actor runtime that's available in Autonomy. And each agent is modeled as an actor. And why is this important? This is important because if you think about what agents do, they go in this loop. We talked about this, right? They go in this loop of call the LLM. The LLM says, call these tools. So they go call the tools. They take the response of the tools, call the LLM again, right? And this loop
Typical.
continues. So when this loop is happening, the state machine, the actor of the agent, is mostly waiting on either LLM inference to complete or a tool call to complete. Correct?
True.
So if you
Very much
take
true.
that and you model it as an actor, when the actor is waiting, you can give the CPU to someone else. So that's a key kind of design primitive in our system is because we assume that agent execution of the state machine is very fast compared to tool invocation or LLM inference, most actors spend most of their life just waiting.
Mm-hmm.
And so, since most agents spend most of their life just waiting, designing them as actors allows us to run thousands of them in tiny infrastructure. So, we can, for
Mm-hmm.
example, last night I created 1 million agents in a single container with 4 GB of RAM, and it didn't even
Wow,
consume
that's
all the RAM,
insane.
right?
Beautiful.
So, uh, this to sort of tie this idea together before you ask the next question.
Yeah, yeah, yeah.
Basically, the key point is that inference currently is too slow. Tool calling to another tool is too slow compared to how fast the state can transition. And with that foundation, it's really helpful to think of agents as actors.
Look, this is beautiful. I want to take it so many directions, but one very quick question. In this experiment that you run with 1 million agents that you started, how many of them can you keep running simultaneously?
All of them, provided they
I mean,
all
using
don't want
CPU.
the CPU. They all correct, right? So
Yeah.
if all of them are consuming the CPU, then
Yeah.
obviously you get constrained. You shouldn't be running 1 million of them in
Yeah.
the same
Yeah.
machine. But if all of them are invoking LLM and invoking a tool outside of this machine, then you can run 1 million of them in that machine. The trade off is how much CPU, and this really comes from measurement, right? So, for example, in
Yeah.
Autonomy, we can give each agent a sandbox, right? So they get their own
Hmm?
shell, they get their own file system. And the moment you give them their own shell, they might be invoking tools that consume CPU. Like, for example, we have run agents that invoke FFmpeg to encode a video. The moment the FFmpeg invocation happens, that starts consuming the CPU. And at that point, you can't run a million agents in one
Obviously. Yeah.
environment, of course, right? But
Yeah.
the example I ran yesterday was someone on LinkedIn posted, hey, what if you are a consumer brand and the consumer brand has a million customers and
Yeah.
you as the consumer brand want to give each customer a helper agent? How would you do it?
Well, yeah, your
And
architecture works for that perfectly. Yeah.
right, because all those million people aren't asking me to do things all the time. They're asking me to do things at different points in time. And so I can host them all in very tiny infrastructure and on demand spin up the tool compute that they need, right? So that's what Autonomy automatically does. So we can run lots of agent state machines in very tiny infrastructure. And when they need to do more work, we can dynamically spin up the sandbox that they're operating in, and we can dynamically spin up the environment. So that's kind of how this plays out.
Beautiful. Look, it seems to me that the use cases that will work best for you are those that require high performance and low latency in the first place, as well as multi-tenancy. And can you outline a few of the real use cases that maybe you already are exploiting with your clients that fit your model well?
Yeah, good question, right? Here are some examples. So one example is someone who has many customers, someone building a product with many customers. Think thousands of customers is kind of the scale we are operating in currently, right?
Yeah.
The 1 million example was me just doing an example, but we have customers that are running thousands of their customers and their agents on Autonomy, right? And in that scenario, the challenge becomes if I have to, let's say, let me, without naming them, let's imagine a fitness app. Okay,
Yeah.
this fitness app gives each agent, each customer, a coach, and the coach is an agent, right? And they have thousands of users. They're a mobile app, and whenever someone is doing a workout, they want their coach to be in the workout and help them and do things with them, right? So that type of model where you want to timeshare simple infrastructure across a bunch of machines works really
Yeah.
well. Their alternative before Autonomy was this really complex setup they had built with Autonomy where what they were doing was each agent was running in its own container. Communication between agents, actually in their case, each agent was running as a Lambda. And it was a
Okay.
series of chain Lambda calls that they were doing. And they
Okay.
built this like complex messaging infrastructure between the Lambdas that would
Mm-hmm.
be like they were running basically SNS queues in AWS, etc. Right? So if they have to support 5,000 customers, they were running tens of thousands of Lambda invocations for supporting those customers. So they had this like complex messaging queue distributing work to the Lambdas. And when you're doing this with Lambda, you start hitting timeout limits with AWS because Lambdas are designed to be short-lived. Agents are
There's
completely
plenty of
opposite. Agents
problems
are
they can run
long-lived.
with.
Like
Yeah.
the architecture is just mismatched, right? But
Yeah.
I'm surprised how many people I encounter who are trying to run agents on top of Lambda, which is just fundamentally the wrong primitive in my view. Right? So that's one example of like someone who has lots of customers. I'll take a different example. It's someone who has some customers, but each customer's workload involves a lot of data processing. So this is the example of like the 5,000 agents form, right? So the example I picked out in that example was, let's say I want to review all the code in a code repository, not one
Okay.
file, not one PR, but all the code, right? Let's say I have 10,000 files and I want to do a deep code review of that code base. Let's say I'm building a code auditing product for security reasons or for compliance reasons, right? And
Right.
there are
Right.
a lot of industries where you need that. So anytime my customer comes, I want to run a full audit of their code bases. And I have many customers. So I want to keep doing this for every customer, right? So now in that example, you give it a single code repository on GitHub. It downloads
Mm-hmm.
that code repository and it spins up a reviewer agent per file in that code repository. So if you have 5,000 files, 5,000 parallel agents spin up that look at each file and conduct a deep code review of it from many angles. And for each
Mm-hmm.
angle, those agents spin up sub-agents because it's easier to manage context in a sub-agent context rather than trying to do a big review in a bigger
Of
agent.
course.
So in Autonomy, you can easily spin up sub-agents because they're all just actors. So each file is now reviewed from a security angle. It's reviewed from a documentation angle. It's looked at from bugs. Sub-agents can write tests and run those tests against the code to see if this file has some problems, etc. Right? And they do all of that in this workspace. So that's an example of you want to do deep data processing and deep work on a single workflow for a single customer, but that work is very involved and complex and takes many hours and a type of thing. So
Mm-hmm.
that's it. That's an example. And I'll give a third example. So far we looked at, I have lots of users where you need
Yeah.
this architecture. The second one was each user has lots of work I need to do, and it's deep and it will take hours
You
to do,
just need
right?
to run. Yep.
Right. And the third example is I need to do things quickly. So this is an example of let's say they're FinTech. They issue loans to businesses. So business
Yep.
calls them and says, "Hey, I would like a business loan." The person who picks up the call at the bank, which is a human, says, "Okay, sure. Can you give me all the documents about your business? Give me past bank statements, give me payroll records, give me past contracts, etc." And they give them an upload URL to box.com and say, "Hey, upload all your documents here." So the customer uploads all the documents, and each customer uploads, let's say, 100 documents about their business, different contracts, payroll statements, etc. And while on the phone call, they want an agent to look at all those 100 documents and
Yeah.
decide if they want to give this customer a loan or not and make a recommendation to the human.
Okay.
So, but this has to happen quickly. So before Autonomy, they were using MuleSoft and Salesforce Agentforce, and they built a setup. And it was taking 25 minutes to come to a recommendation using those agents that they had built. With Autonomy, they were able to do the same work in 25 seconds. And the reason was they created parallel agents that looked at each document in parallel and did the assessment really, really quickly rather than in some complex sequential pipeline, right? So this is a scenario where a customer wants stuff to happen quickly. And if you think about it, they're not talking to one customer at a time. They're a large financial institution. They're talking to
Yeah.
hundreds of customers at a time, right? So for
Obviously,
each
they have a
customer,
huge
they
load.
want hundreds of agents working in parallel. So their
Yeah.
product needs thousands of agents working at all the time. And that's what Autonomy unlocks.
Beautiful. Listen, you did explain to me some of the concepts of why, but I can't tell. I guess what I'm missing over here a little bit in the story, I do understand the focus on latency and parallelism, and I do understand the efficiencies that anyone can gain with running multiple users or running multiple agents doing the same stuff against different data sets. But I wanted to ask you about actually communication between those agents, because that's like the actual orchestration in between them, and whether it's happening within your platform, and if it's happening, then well, uh, I guess how, broadly speaking, you know what I mean? Like, is it a use case for you when you have, I don't know, 1,000 agents and 200 of them is one type and 500 another type and 300 a third type, and they somehow communicate between each other?
Yeah, that's a core functionality in Autonomy. So, excuse me. This started with work I was doing in an open source project called Occam, starting from 2020. So
Yeah,
Autumn is a highly performant encrypted messaging system for use within other systems, right? So it's like WhatsApp, but for applications, right? Yeah, that's a good way to think
yeah,
about it. So if you're building an
yeah. I remember
application with
you.
a distributed, yeah, it's like a distributed environment. You want all of them to talk to each other. Occam's a really good toolkit for that. It's a Rust library. And so in Autonomy, we use Occam for all of that communication between agents. And so the combination is in a single machine, our actor runtime is moving messages between agents, right? But
Yeah.
when it goes across machines, Occam messaging is moving the messages between agents. And because it is Occam, and Occam can do encrypted channels from anywhere to anywhere, you can have agents in autonomy talking to other agents on the same machine, or you can have agents in autonomy talking to other agents in a distributed cluster of machines that are all operating inside autonomy. Or
Mm-hmm.
you can have agents in autonomy collaborating with agents in my private data center or agents
Yeah.
inside my private VPC, right? So this collaboration fabric that Occam unlocks allows us to have distributed fleets of agents. These could be in a data
Mm-hmm.
center, in a private VPC, or even an autonomous car, right? All of these
Mm-hmm.
agents can collaborate with each other using the autonomy framework. And to do that, you need some primitives. You need to be able to trust who you're talking to, right? And you need to be able to reach who you're talking to. So Occam provides that reach because it can do encrypted channels over multiple hops of transport layer connections. And these transports can be in different protocols if you want. And so it can traverse NATs and network boundaries in very interesting ways without requiring public endpoints. Secondly, you need to do trust. And to do that, all agents in autonomy have a cryptographic identity, and they can be issued cryptographic attribute based credentials, which
Mm-hmm.
allows them to do mutual authentication and then reason about trust and make policy decisions around access control based on the credentials the other side presents. So if the financial system says, hey, this agent is my agent operating in a different data center, then the agent that's asking it for context around a certain piece of information can trust it, right? So in autonomy, that primitive, that foundation is built in because we build autonomy on top of Occam. So that's one piece of the puzzle. The other piece of the puzzle is, how does work even get distributed? Which is, I think, partly where you were going, is like, how does
Yeah. Yeah.
work even
Exactly.
get broken down and orchestrated, right? So once you have this basic mechanism to create subagents and delegate work to them, which in autonomy, they're just actors. And so we've written tools that we can give a parent agent that allows the parent agent to spin up a set of sub-agents. It can spin up one agent or it can spin up 10,000 agents, doesn't matter. It just has a tool to do that, right? And so it can autonomously spin up lots of agents, and we tackle all the infrastructure under the hood. But then comes the question of how is work distributed? And different patterns apply here. So a really common pattern is like a scatter gather, right? Or a fan in, fan out, or map reduce. These are the names for
Mm-hmm. Mm-hmm.
is of the same thing, which is, I have a list of things to do. I will take each item in the list and give it to one agent, right?
Mm-hmm.
So
Mm-hmm.
let's say I have
It's
5,000
like.
documents to assess, or I have 5,000 source code files to assess. I take one file and I spin up a subagent and give that one file to that subagent. And so now 5,000 parallel agents are tackling these 5,000 files. And at some point, they're going to reply back. And when they reply back, I have to summarize this result
Right.
and compress it into a final output, right? So this is the
Right.
simple kind of scatter and gather flow. Uh,
Mm-hmm.
that's the most common pattern. And it's a really powerful pattern in my view, because most problems, if you think about it, of like, how could I scatter gather this problem? It unlocks very quickly that most problems can be broken down like that. Most work is parallelizable in that way. There are some exceptions. There are work that must be happen in sequence. And at that point, scatter gather doesn't work. And then you have to have the orchestrator agent or the parent agent trigger different
Mm-hmm.
tools
Mm-hmm.
one by one. But the latest models are very good at that type of decision making. They can choose that, hey, this work is parallelizable, so I will create a parallel fleet of agents. Whereas they
Mm-hmm.
can choose in a different case, this work needs to happen in sequence. So I will do agent number one first, and then agent number two first, and so forth. So those are the two common patterns. And the third piece is when you need subagents to collaborate and communicate with each other and do some negotiation, for example, or
Yep.
arrive at a consensus. That also is supported in autonomy because agents can send each other messages. So what we do is we spin up an agent with a tool to deliver a message to any other agent or any other subset of agents. And
Mm-hmm.
then they autonomously exchange messages and arrive at a consensus. This one is the least successful as a solution, in my view, because the current models tend to go in infinite loops a lot. Like they don't arrive at a
That's true.
conclusion all the time, right? So
Yeah.
I think we'll get there in some time. But in autonomy, the basic infrastructure for all these primitives exists, whether you have a deeply parallelizable problem, like lots of
Yeah.
documents or lots of source code files, or you have a sequential problem and you want to do one at a time, multiple agents, or each step might be on its own swarm of agents. You can do that also. And then the third piece is you want agents that collaborate peer to peer and negotiate peer to peer. That also is possible. So the fundamentals exist, but I think that on the last one, the models are still catching up.
Yeah, I agree with you. I think I was actually looking at the research the other day on specifically the orchestration of the agents. And beyond basic models like hub and spoke and the ones you mentioned, there's not much that we know on how to properly orchestrate them. So, you mentioned a lot that you have this cryptographic identity, which is very interesting, and as well as, the constant problem that I'm seeing and that I'm dealing with is credential management. So I saw your post about collaboration with OnePassword. Can you tell a little more about that? What does it bring you? What does it bring to the table for autonomy?
Right. Good question. Thank you. So agents don't operate in isolation. They need to work with other systems. And these other systems need credentials so you can access them, right? So you need a secret to make an API call, or you might need a
Yeah,
key to talk to some system, right? So you need these keys to external systems. And the problem is partly that traditionally, most secrets weren't designed to be used by agents, they were designed to be used by humans. And so the challenge we have with protocols like OAuth or protocol or approaches like having an API secret is that those the secrets tend to be very long lived, relatively speaking.
yeah,
And agents actually can do scary things autonomously. And so we want to kind of, it'd be good if we can scope their access and tightly control what they are allowed to do, right? And to
yep.
do that, first step is you need to be able to know which agent is asking for what action. So identity is a first step. You must know reliably that this is the agent that's asking for this access, and this is the agent that's going to take the next step. So in autonomy, we have this baked in primitive that every agent is as a cryptographic identity and all communication is authenticated, which means that all actions are attributable to a specific agent, which is a really important first step. Next step
It's a
becomes
key,
this
man.
agent
So
wants,
important.
so the next step becomes that this agent now wants access to other systems. So it needs to access secrets that we all that give it the ability to talk to another system, let's say an API. So traditionally, what used to happen is that these API keys, you'd go get them manually on some dev portal, and then you'll add it to your backend system, and then you won't change it for like a year, right? It would stay there. But if you're giving it to an agent, the risk is that some leak might happen, some problem might happen. And so instead, what you want to do is you want to create an API key that is specific to one agent and it only lives for the time span that the agent needs it, and then it cannot be used later. You want to go from long lived keys to short lived, time bound, scope limited keys. And so our collaboration with OnePassword was to show how you can have a system where secrets are accessed in this scoped way with human approval. So when an agent is asking for a secret to a specific thing, a human gets to approve whether or not that secret is allowed. Once they approve it, the secret is time bound and expires after little time. So the exact scenario we showed with OnePassword is, let's say you have on-call SRE agents and a swarm of them. So a problem is detected in your cloud infrastructure. The SRE automatically spins up and starts a swarm of diagnostic agents. In that case, we showed like 184 agents diagnosing the problem in parallel across your services. So initially, for diagnosis, they only need read-only credentials, right? So we showed that the agent can ask a human to give it approval to just access read-only access to the database. But then later, when it has figured out the problem, it now has a plan to remediate. And at that point, it can ask the human again, hey, can you give me a different credential that allows me to make some changes, to disable a feature flag, or to kill some queries in the database? And at that point, the human can approve and say, yes, you have access to this for 10 minutes. And in 10 minutes, fix the problem, and the credential you'll have will expire after this. So this combination of autonomy and OnePassword allowed us to show how having agent identity and a good protocol for authenticated communication and time limited credentials unlocks agents that can be more capable, like automatically fixing problems in your cloud.
Man, this is beautiful. I use similar concept called like basically it's like ephemeral keys that are limited in time, and you give it to an agent and it expires in a bit. But I really like this approach that you guys used for uh, kind of asking for permission from a human, like a human in the loop kind of thing, where a human approves by giving credentials for like 10 minutes and saying like, okay, there's a little open door, go fix it, but then you're back to normal.
Yeah,
That's
exactly.
really interesting.
Okay, let's switch topics a little bit. Tell me a little bit about what you're building and what types of use cases are you seeing for your platform?
So actually, it's very interesting to talk to you exactly because of what we are building. We just recently dropped Trinity, which is our platform for sovereign agent orchestration and infrastructure. And there's a bunch of ideas that go into that. Yeah, my idea is that actually, as well as in your case, in order to get the best results out of the agents, you actually do need to own them and to be able to very quickly change what you have within them and put it on production and put it in the autonomous mode where it can function. So again, the goal of the whole Trinity platform is to orchestrate autonomous agents and do that in a way that enables humans to have full control, observability, visibility, encryption, and all of this enterprise bells and whistles that are absolutely required, as you know, in order to function there. However, unlike you, we're using a bit of a different approach. So, and it serves a bit of a different use cases. The agents that we run are separated into sandbox within their own Docker containers. And each of them is given enough, resources depending on what the task they need. They are basically synchronized through the GitHub as the main kind of exchange framework for and the version control for the agent and the rest of that. And the main use case that I'm enabling right now, at least for myself, because I have built that for myself first of all. Let me tell you a story, probably familiar to you as well. For last, well, a little less than a year, I'm a big fan of Claude Code and Gemini CLI and other things. And some time ago, I started building, well, about a year, I think, I started building my first business-oriented agents rather than coding agents. So I made myself Corbin that manages all my business operations and keeps track of everything. I built a Ruby that is working on my entire social media, and I would be excited to just talk about that for hours, honestly. It's quite
Interesting.
cool. But I run into a wall because my Claude Code agents are running on my local computer. They're not parallelizing properly unless you're calling like sub agents and orchestrating it differently. I have to keep it open. I have to keep resources busy, and I cannot enable autonomy mode on those. So I was like, okay, what do I do? And I built Trinity where I can, in like one click, deploy it to the remote version. And now I have two identical agents, one of them running locally on my local computer, and another one running in a self-contained sandbox in the Docker instance in Trinity with all the bells and whistles of control over the containers and credentials and the rest of this stuff. And I've built a process around that allows me to basically connect them from local to remote and have remote execute autonomous tasks of the local. So say I'm building this Ruby agent that is doing my social media. In the Ruby agent, I have this skill that searches Twitter for the potential replies, for example. And once I get to the point that I develop this skill to the level that I'm happy with that and it works perfectly every time, I can simply schedule that on Trinity and it will run autonomously from exactly the same version of the Claude Code, from exactly the same version of the agent, actually, which guarantees exactly the same results and notify me back in my Claude Code if something requires my attention. So that's the use case that I use it for. There's a bit of a different angle if we talk about the use cases as well. we as a company, we are a solution provider. We go to businesses and we implement business process transformation with the use of agents. And now we're using our tool to do that. And there's plenty of various use cases that can be described there that are implemented on this platform. But those that I think would be interesting to share are around content pipeline automation, and the one that I mentioned with Ruby. There's around the knowledge management automation that is Cornelius agent that has this whole second brain concept behind that. There is business management and operations workflows that are running there. And I even published my first movie yesterday. There's that was created fully by an agent running on Trinity
Very cool.
from
Wow.
beginning to an end, which was like, it was pretty exciting anyway. And yeah, and the idea again is that I can have whatever number of them. I'm not running thousands, but I'm running something like 12, 15 agents simultaneously. And these agents are aware of each other. They can talk to each other as long as this permission is enabled. And they can talk to each other through the standardized MCP, obviously. And we can implement and successfully implement various kind of orchestration patterns over there. Usually what actually works for us in several use cases is the orchestrator model, when we have a controlling agents that runs the rest of them and gives them command and validates it. And then what we added to the platform is basically an ability to set permissions carefully, to share folders between those agents so they can work in each other's workspaces if that's necessary. And added on top of that observability and evaluations, evals that we need for these agents, as well as the human in the loop control, which I think is one of the key elements of this, because it basically enables to build it into the business process of a company and literally define that, like, listen, this agent is responsible for that, this agent is running this procedure, this agent is running that procedure. All of these procedures are nicely stored in the GitHub repository, so we can go ahead and edit them, and then we can just sit and observe how these agents are running, exchanging messages, and doing their own stuff. So yeah,
This is super
that was a
interesting.
long answer.
No, that was super, super interesting. And I can totally see how the approach you've taken is different. I can also see how what we're doing is like complementary. So let me illustrate. So in my mind,
Yeah,
scripts, there's a set of automation that should be scripts that are highly personalized and are almost like an extension of the person. And I think what you're doing with Trinity is kind of like that. I have some work that I would have traditionally done manually locally on my machine. And
yeah,
I want to extend that to the cloud and have agents help me do that better, more scalably, and move forward, right?
and
But the
autonomously.
workflow
Yeah,
is and autonomously, right? And the workflow is very tailored to me, and I try to tweak it all the time because it's my personal extension, my personal script, right? So there's
yeah,
that category. And there's this other category, which is, I think, where autonomy is, which is we as a product builder think lots of people have this exact same use case, and we're going to productize a solution for that use case and offer it as a service to many users. And I think what will happen is the personal script agents that are extensions of me will work with productized services to further
yeah,
go get new capabilities, right? So I think
yeah.
that the two approaches are almost like complementary and very powerful areas on their own. So that was really interesting to hear. And there are a couple of other things that you said that are, I think, are very important to highlight, which is um, I think there were agents built over the last 2 years
Yeah.
that are effectively going to get rebuilt. All of them. They're giant companies with billions of dollars raised that have built agents. And the way you described it and the way I
Yeah.
describe it, we already realized this. But they've built agents for technology that is not relevant, not the bleeding edge anymore, right? What they've done is build like little workflow orchestration things with some simple thing like a lang chain or whatever. But if you think about where the world is now, what you need, what is possible is you can have agents that can do complex, deep work autonomously. And
Exactly.
this allows the agent to take thousands of autonomous steps, whereas the last generation of agents could take 2 or 3 autonomous steps and then would get lost, right? So by giving an a file system, a workspace, the ability to take notes, the ability to run shell commands, the ability to generate code on demand and run it, which both of our platforms have. In your case with Cloud Code, in our case, Autonomy agents have these exact same capabilities. A new level of autonomy gets unlocked, right? A new level of autonomous work gets unlocked. And I think what will happen is a lot of investment that happened over the last 2 years in agent, the first wave of agents, I think is going to get redone, right? So I think there's a ton of opportunity in the market as people realize that actually the first generation of agents weren't very capable. And to have really
Yeah,
capable autonomous agents, you need to give them a full working environment
100%.
like Trinity or Autonomy.
100%, man. To take it even a step further, and I think that can reinforce the concept that you guys are running and that we are running as well. I am not a believer in SaaS type of agents anymore. Those that are built by one company and reused in the same fashion by thousands of people, simply because, well, not simply. There's a number of reasons, but the fact that they have to put too many guardrails around it and make it dumb because they have to limit from the public attacks on the prompt injections and stuff like that. The fact that they are slow to change and adjust to the new technologies that are appearing, which is what you basically mentioned. And I think this whole narrative of let's build sovereign, let's build on, on the edge, basically, on our own on-premise installations and our virtual private clouds, things that we can control. Because when we can control it, that means that we can adjust it and change it very quickly to whatever comes next. I don't know. Maybe there's some other revolution that is coming. But yeah, just a thought that I
So I
really
have
am betting on
that's
this.
a I think because everything is changing, it's good to hold opposing views and different teams to go after different things. So
Yeah,
I am very much a believer in that approach. I think products have value that accrues in some very interesting ways, right? So a product um, allows one user to benefit from learnings across thousands of users.
right.
But
That's
if
true.
someone is operating in their own environment, that learning slows down and it becomes more challenging. The other thing is that a product offered as a service can share actions across these users. So, for example, let's say a security vulnerability comes out, and let's say someone has done these sovereign deployments across many customers. Getting all of them to upgrade and get to the latest state can be quite challenging. Whereas in a product, the central service can control this, right? This is not to say that both things are not needed, but this is to say that there's different value propositions in products offered as services. Given how much success our current customers are having by operating that as a service product model, I continue to kind of like bolster my belief in we're in a transition currently where people are kind of like experimenting with both
Yeah,
approaches.
yeah, yeah.
But my bet is that we will lean back towards lots of things are offered as products, but also lots of things operate in my control.
Yeah. No, that's interesting. Look, it's a good discussion to have. It's a good to have opposing views, obviously, because we can find the truth somewhere in the middle. But to give you a bit more of my thoughts on this topic, and maybe we're talking a bit of a different things when we mean agents offered as a product. But I think one of the key metrics going forward for any business that is running is going to be a sort of a creativity per second, meaning that they need to move fast with their agents, so change them fast, and they need to put in a lot of creativity into that in order to make the difference. And once, if you're relying as a company on usually 20, 30, 40 different agents that you are renting from other companies, you are limiting yourself to their speed of change. That's one of the factors to take into account. And you're limiting it to averaging out of their products. What I mean is every company that is proposing a product for rent, proposes an agent as a service, they have to satisfy a large amount of audience by making this agent kind of similar for everybody, more good for everybody than individually for you. And I think that's where the competitive advantage in the future is going to be coming from. You need to be unique in a way with what your agents are doing in order to make the difference. That's my kind of futuristic a little bit look into that.
Yeah, this is a super interesting discussion. We're making different bets, which is okay, right? Because this is a time to bet on the future. But
Yep.
illustrate my thinking on a different era. Okay. So when cloud was getting started,
Yeah.
I had a friend who ran a chain of hotels. Like he was a hotelier. Okay. And cloud was just getting started. And he was like, hey, I, everybody's moving their email to the cloud, but I'm really scared. Like or there's like a lot of sensitive business information in our email. We operated as Exchange servers internally. This might be 2000. I think I'm thinking like 2005, 6, 7. So that's the
Mm-hmm.
time frame. Okay. Um, and so he's like, hey, I'm really scared. Like, what should I do? And I was like, okay, how many people do you have on your team that manages these email servers? He's like, we have 2 full-time IT people. We also have some outsourced consultants that help us. But, those 2 people are the operators. I was like, okay, that's interesting. And where does your Exchange server run? He's like, we have the main hotel in its basement. There's like a data center room. That's where, we're running our email server. And so I was like, okay, now think about that 2 people versus the number of people employed by Google to operate Gmail, or the number of people employed by Microsoft to operate their email as a service. Think
Yeah.
about the background of that group versus the 2 people you hired. You hired the best 2 people you could find. They hired the best 100 people or 1,000 people they could find the world over. And so the benefit of those teams of people starts to accrue into that Gmail product, which was admittedly inferior at the time compared to what they were operating in many ways.
Yeah.
But
Yeah.
it had a curve of improvement that could be a lot better because it was funded in this other way, right? So the story is my way of sort of illustrating that there are different trade-offs in play when choosing thing to operate yourselves versus a thing that is operated by a team that's where their entire job is to operate that thing well, whereas the 2 people in my IT org might have 10 things to worry about, right? So they're different trade-offs, but we could debate this for years and not arrive at a
Yeah.
consensus. My view is that there are different bets to make, and I think different things will take off, and we'll see how this next wave plays out. Yeah, it's
True.
exciting.
But let me throw in something else. It's just so interesting. Look, I am not arguing against SaaS software necessarily. I'm arguing specifically against agents over there. I do think that we will still have software as on a subscription, and we will still have data on the subscription, which is what is driving the agents to make good decisions. But that's not what I wanted to mention. You see that we're going in the direction, and what you mentioned is completely valid for 2007, where, in order to build and maintain your own software or your agents on premise, you actually needed a ton of people. And those people needed to be good in order for that to be good. The difference is now you don't. Now you only need agents who can be doing that. And the further we go, the more of the agents you're going to need. So my bet is that we're going to end up with the systems that are so autonomous that they're both building the systems and maintaining that. And the input of a human, the level of creativity that human puts in their input in terms of what they want the agents to do is what is going to be making the difference. But again, as you said, I totally agree. We can talk about that for ages. It's very exciting,
I
but
now have one more point to make, and it's actually
okay,
outside
go,
of this
go.
debate. I'll make it differently, okay? So what you just said reminds me of, a meme that's kind of going around in technology circles that I've seen. Like,
Yeah,
I've seen people talk about, hey, we're going to see a single person company be worth $1 billion soon, right? And my reaction always to that is, well, okay, so if I figure out leverage where I realize that one person can create $1 billion in value, it's not going to be that today I don't know this and tomorrow it suddenly be $1 billion. It will be over a period of time, right? Over a period of time, I realize that actually, oh, look, I made $1 million. Oh, look, I made $10 million. And I think that someone who gets to $10 million will suddenly go, well, okay, on my own, I made $10 million. If I find someone else that has almost the same skills as me, could I make the next 10 faster? And so I'm going to start looking for the next person that could help me grow faster, right? And when I add the second person, if it works out well, I'm going to go, well, what happens if I add a third person? Do I grow
Hmm.
even faster? So this is to say that, in my view, humans have always added leverage to whatever our automation technology is of the day, right?
Hmm.
So, in the last generation of cloud, was that if you hired the right expertise quickly, if that was your skill, that was Google's skill, that was Amazon's skill, hire the best people in the world as quickly as possible. If you do that, you create this point of leverage in being able to produce more capable things faster than others can move, right?
Hmm.
So I think that to go on a complete tangent in this like $1 billion company example, I think no rational person will get to $1 billion alone, because they will realize along the way that actually they can hire more people like them and get to a lot more and $1 billion faster, a lot more money overall, because the market they're operating in is is not capped at $1 billion, right? So there's room to grow. So this is to say, I think that uh, the way it will play out, and we'll see how it goes, but the way it will play out is everybody will get amplified, but we will still have the same org structures. We'll still have people involved, because people are levers in that amplification. So this is my kind of personal view, thinking about like how
Hmm.
it will play out. Like currently, a lot of people are talking about we'll reduce the size of teams, but I suspect what will happen is we'll just do more things faster, and we'll again need more people to do it.
Interesting view. But I think, yes. So as part of what you were saying, you mentioned that human is a leverage, because if we take an example of Google, for example, or Amazon, that we're hiring a lot of the smart people faster and created leverage because of that. If we take that analogy and look at what is going on right now whoever is capable of building agents faster and more intelligence and orchestrating them in a way that brings a lot of additional value is going to be creating this leverage. And it feels to me
That's
that
correct.
those can still be very small teams. I can tell you myself, we have 11 people in the team. Everybody is a bit of a full stack, not in terms of engineering, but in terms of the business. So they all build agents, they operate these agents, and they do something with that. That's a new way of organizing kind of this sort of a teams. But I can tell you that and maybe you noticed that yourself as well. It is very easy for me to work on an agent and build an agent that is very high performant and deep in what it's doing and thoughtful with the right procedures and the rest of that. It is way easier for me to do so myself than to explain to any other human what exactly I want them to do there. And I'm running into this issue all the time, because if I can explain what I want this agent to do, then it's as easy as prompting this explanation with all this other stuff to the agent to make it happen. And for me, that creates, so what has been our leverage in terms of team collaborations is becoming the weakness. I feel like the more links, if I have to have an agent that is controlled by multiple people, it's going to develop way slower than if it's controlled by one people who knows what they're doing, one person
Possibly,
over
possibly.
there.
I agree. I think I've also encountered there are multiple companies here in San Francisco that I've met that are trying to become that middle manager. Basically, you give your description to an agent. The agent
Yeah,
writes more detailed descriptions to delegate to
yeah,
humans and agent teams, right?
yeah, yeah.
So
That's also
there is
murky.
there is that potential layer in the middle that could exist. But I agree. I think
Yes,
like everybody's discovering what is the right way to work as we go forward. But it's an interesting time to be a
it's such
builder
an exciting time.
of agents.
Yeah, for sure. Man, thank you so much for your time today. It was an exciting discussion, and I hope we can pick it up next time. But thank you. Maybe you have some closing words over here as well.
Thank you so much for having me. Super fun discussion. I always enjoy talking about this topic. So thank you, and thank you to all your audience for joining us and listening to us talk through this.
Just give me one more second. My camera will come back. All right, folks. Thanks everybody for listening. Don't forget to subscribe and like this video and watch the other stuff that comes out. And other than that, have a great weekend. Bye-bye. Or no, maybe not have a great weekend. Have a wonderful day. Bye-bye. Because I don't know when I'm actually going to get it done.